Alrighty, so this is the house framer I've been working on. I want a model that I can actually go through and destroy. So I kind of want all the bits and pieces existent in it. If I turn off in Geo-Nodes the actual show component, you can see it's just a bunch of cubes, really one marking out each room. Then some controls for marking the wall height, its thickness, the beam width I think is half the height, so it's how thick that beam is, and I'll just undo that. And then of course the size of the foundation. Now it comes up to the corner here, and I've attached the particular nodes and stuff. So anyhow, I'll do a breakdown for the node tree. I've worked a bit more on actually the frame itself, and I've got a roof happening, but it's still messy. So since I don't like it, I'm not going to include it. Alright, so the first component I really worked on was the actual bottom of the house frame. So if we start disabling all the irrelevant stuff, and I'll turn off the foundation, we've got the original geometry and then also these beams. So the beams themselves are really quite simply constructed. The thing that makes it happen is actually converting it from the geometry, which is all the edges, into a set of separate lines. So tabbing into this node, it looks complicated, more complicated than it is, but basically converting the separate edges into curves. The curves will only have 2 points, and then adjusting each end appropriately. Now we're adjusting it based on the tangent of the curve, so I can extend beyond that length. To give you an active example, if I disconnect the extend part of this function, it extends 0.7 by random, or that sort of thing. But in this case, I think I added in the wall thickness to get it to the very end so that they overlap. Yeah. From there, it's going through and convert that curve to a mesh, but taking the quadrilateral, which is just taking the thickness of a beam vertically, and then the wall thickness, which is across the top. So basically wall thickness will run, if we just look at this and get the thing, so that wall thickness runs that way, and that way is the beam thickness, which then gives us what we need. Alright, moving on. I then constructed the actual wall studs. This is the risers that come up, so you can see those here. Because I knew the top would be fairly easy because it's just a repeat of the bottom just shifted. And in this case, I wrote this function, which is just designed to shorten the curves. It's a little simpler than the previous one, but basically, again, convert the edges into curves, and then use the trim curve function just to cut the end in by a certain amount. I use a set curve radius at the end of each of these, so that I don't get any weird distortions along the edge of the thing, because what I was noticing is it comes out and then comes in, stuff like that, on the various curves that I'd created because of this thickness adjustment. So if you want to, the geometry nodes, that's for this this group, and how I get it used to actually build the studs themselves. So again, this time I'm actually converting the curve, which is basically these curves along the bottom here, into a series of points, and then using those points to add a mesh line to go up. And then from that, I convert those mesh lines into, again, the quadrilaterals, which would be the beams of that size. And then basically tack it on top as this thing. There's a little bit of a height adjustment from the z-axis just to bump it up above the thickness, because this mesh, if I just go to a pure side view, I think will work. No, this will be clearer. This is where my mesh sits. Then this beam, which is this bottom of the wall frame, sits there, and then I want these tacked on top, so I have to adjust them up the height of that beam, which is why it gets factored in here, before I actually set the position, shade it flat, and then realize the incidences before joining them all up with the rest of it. Then the next stage is the top of the frame. I'm grabbing that, plugging the top in, As I said, it's really just rinse and repeat of the previous one. You can see that they are virtually identical. The only shift is, instead of taking half this distance in height of the beam width, what I'm doing is I'm doing a multiply add, and the multiply add is basically taking the beam width, timesing it by 1.5. So instead of by half, it's by 1.5 to adjust for the heights of everything, and then adding on the height of the wall. So yeah, and I'll put this up on Gumroad so that people can download it if they want to have a closer look at what I've developed. Then we need thicker studs at the ends. I decided to go with thicker studs because doing thin ones was a pain, because classical house construction is you've got two beams like that at the end and then one overlapping in that way, and building something that would occupy that space and fitting it on here was beyond my brain. So what I did was I cheated. I did thick ones. If I turn off, disable the top and bottom, and you can see here that that's just square. Nice and easy. So this one, again, trim the curves. I don't need to extend them at all, they're just the same length. But all I'm using this for is to convert this into, what do you call them? Edges. Edges into curves. And then basically take the points, i.e. one at each end of that. I guess I get some double ups over here, but that gets resolved down the track with a mesh boolean. Alright, so once I've got that, I'm only concerned with the Z rotation. X and Y is irrelevant. So, and I found if I included all of them and did a direct link, it was problematical, so I just cut it out so I only kept the X. Then with the quadrilateral, taking the height and width, because they're basically a square, so it's just that width there, and just make it square along here. And then make the curve line the height of the wall. Nice and simple. Make that a mesh, make those the instances along these various points here, here, and all the way around. Set the position so that they are bumped up above ground level. So looking at ground level, you can see that they're bumped up. Nice and easy. And then from there, shade smooth, realize instances, and then mesh boolean to basically get rid of any additional geometry. So joining these two on, we then have the foundation. Now I struggled with the foundation a bit. I made use of the edge offset node from Haggis's tools, and looking at the complexity of this, yeah, there's no way I could have built that. I did have another function that I'd created, but it was trash. So I'm glad I went with this. So first, just a vector to basically force it downwards. Then if I turn this on, you can see this here. And all that node does, that edge offset, is take it from this point and push it out that much. It's really just the foundation expansion is supposed to push it a little further. You can see that there. And a set of 0.45, which is half the wall thickness, because the wall's traced along half that distance. So that tacks it along there. Then adjust the faces and join the geometry, so I've got one solid cube down the bottom. And then merge the distance to get rid of additional vertices, and then the switch is just a controller so I can turn it on and off. And that's basically the house framer. Not much more to add to it really. But I wanted a set of geometry that it would be easy to create, and when you go in and destroy it, it breaks into appropriate pieces. It's not just what I would refer to as a shell message. It's not just the appearance of the outside, it's actually the internals as well. And then of course I can add colouring and shading and all that sort of stuff, materials to it down the track, but this is still sort of halfway through construction. But I thought I'd get this done just to sort of cap off a week's worth of work and stuff. Alright, so as I said, this is here, it's available on Gumroad. Have a look at it, let me know what you think and that sort of stuff. Thanks for your time.